خفيفة. الله
الله
يخليك.
يخليك.
راعي ظروف الطلاب.
الله يحفظكم. Okay. Now, just to remind you, last time, you remember we talked about exact equation. We mentioned that exact equation is coming in this form: mx plus n dy equals 0. And we mentioned to solve it as exact equation, we need to satisfy condition. The conditions say partial m over partial y should equal to partial n over partial x. It means my should equal to nx. Differentiation of m, this is m, with respect to y should equal to differentiation of n with respect to x. Now the question here, what if this condition is not satisfied? The answer is we cannot solve it as exact equation. So what we should do, we can look for function. Let me say the function or the factor is mu, where mu is function of x and y. This factor, if I multiply by the equation by m dx plus n dy, definitely by 0 will be 0, then the new equation will be exact. It means, let me change the color just 1 second. Okay, it means the new m will be this part, and the new n will be this part. Okay, now this factor, we call it integrating factor. Integrating factor simply is a factor. We will find it to multiply the non-exact equation to convert it into exact, and then we solve it. Very simple and very straightforward. How can we find it? Have a look. When I multiply it here, as you can see, I multiply it here and here. This is the new m. I differentiated with respect to y. It should be equal to mu n differentiated with respect to x. It means this part will, when differentiated, will be equal to this part. Very simple. Now, based on this, I want to find formula. I want to find formula for this integrating factor. How can I find it? Have a look. Now I will say, okay, this here, mu m, is two functions. So I can't differentiate in this way. uv equal u dash v plus vu dash. You remember how we differentiate multiplication of two functions? So mu my, mu ym, and mu nx, mu xn. Now rearrange and transfer from one side to another. We are here. Now next, I'm talking about the theorem here. Later with example, it will be very easy. Have a look. Okay. Now next, let's assume mu is function of x only, or function of y only. So if it is function of x only, it means partial mu over partial y. Sorry, d mu over dx directly. So we can write it in this way. From the previous equation, it will be my minus nx over n mu. And if it is function of y only, then partial d mu, over dx dy, there is no partial now, equal nx my over m mu. So either we use this formula with this formula, or this formula. One of them, we can find mu, the integrating factor, which converts the non-exact into exact equation, either as a function of x or as a function of y. Okay. Now let's come and try to find the general form for it. It will be mu equal, if it is function of x, is exponential the integration of my nx n over n dx. And if it is function of y, exponential integration nx my over m dy. Okay, let apply this in example. Have a look. Have a look. Now he gave me this equation. He told me differentiate. I will come. Okay, I will say this is m and this is n. Okay. Now let me find partial mu partial m over partial x y. Here this is m, as you can see. This is n. Partial m over partial y. Where is m? Just a minute. This is m. If I differentiate with respect to y, it means it will give me x, because differentiation of y is 1 by x, comma partial n over partial x. Let me differentiate this with respect to x. Differentiation of 20, 0. This one also 0. What about this? It will be 4x. 4x. This part is not equal to this part, so I cannot solve it as exact. It is not exact because the condition is not satisfied. So what should I do? I go for integrating factor. So let me just remind you, these are the form. I will find this or this, one of them. One of them is enough. Now I will find this fraction and this fraction. Which one is the easy to integrate? I will take it as a integrating factor. So have a look. I will say, okay, my minus nx. By the way, this is my. This is my. And this one is nx. I substituted, okay, x minus 4x, as you can see here, over n. N is this one. I got this expression. Let me try the second one. Okay, I try this one now. Let me try this one. Nx now minus my over m. This is m. I got this part. Now my question to you here, what do you think? What do you think? Which one easy to integrate? This part or this part? What do you think? The first or the second? Excellent. Excellent. The second. The second is easy. You see here, integration 3 over y dy. Okay, I will take 3 outside. Exponential, it will be 1 over y. 1 over y dy. When I integrate, it gives ln y, right? Now I take this 3, it will be power. It will be y to the power 3, like this way. Ln y to the power 3. Ln with exponential, what is left? Y to the power 3. Now just let me erase this so I can continue because I need space. Okay. Okay. Have a look. Right. Okay. Now this is the original function. I will multiply it, the whole function, by y to the power 3. So y to the power 3 times my to the power 3 y, sorry, it will be x y to the power 4 dx plus y to the power 3. I multiply it by the whole expression here. It will be, as you can see here, 2x square y to the power 3 plus 3y to the power 3 y to the power 2 y to the power 5 minus 20y to the power 3 dy equals 0. Now this part represent n and this part represent m. Sorry. Okay. Now let me check the condition. Is it satisfied now or not? Partial m over partial y. Let me check this one. It will be x. There is 4 here in front. There is y to the power 3. Okay. Now let me check the second one. Partial n, this one. Okay. Over partial x equal. Now this is 2 by 2, 4. 4x. And this is y to the power 3. Let me check. Are these equal? Yes, they are equal. Okay. Then this is exact equation. If it become exact equation, I go to solve it as exact. How? You know, I don't need to explain. You know how to solve it. You know the procedure. You use the same procedure. f of xy. You remember the procedure? We remember it's the steps. We follow. We just follow. The function changed, but the procedure is the same. F of xy equal integration m dx plus g of y. We integrate here. Then we will say partial f over partial y equal. We differentiate the equation. Then this to be equate to n, and the final solution to be integrate again to find g of x of y. Then we substitute and equate to c equals 0. It's printed here in our mind. We don't forget it because it's a procedure. 4 steps to solve any exact equation. So you know how to solve it, and this is the final answer. I leave the solution for this one to you as exercise. Try it, you will find it. I think it's easy now because we practice on exact. Now, just let me summarize. The main point discussed today is how we find the integrating factor, which when we multiply the non-exact equation, it becomes exact and we can solve it. We have here 2 rules. When mu, the integrating factor, is function of x, when the integrating factor is function of y. We either use this one, and based on what we use it based on the either this one is, which one is the easy way? This one 3 over y, or this one, the fraction here? Definitely we'll say this one is easy. Go ahead for this one. Now I will stop here. Linear equation to be discussed inshallah next session, because I spent most of the time trying to fix my computer, and we will continue next session inshallah.
Okay, Doctor, thank you.
Okay.
Doctor?